Welcome to this section on compressible flow. So what we're going to do over the next few lectures is we'll talk a little bit about some review of thermodynamics. We'll talk about the speed of sound. We'll talk about a thing known as the Mach cone. We'll talk about isentropic flows. You might remember the term isentropic from your thermodynamics class. In fact, a lot of compressible flow actually involves thermodynamics, so you'll want to brush up on that topic. Specifically, the thermodynamics portion involving ideal gases. So we'll talk a bit about isentropic flows and some reference points called stagnation and sonic conditions. And then we'll start to analyze or look at flows where we have some area change and how that affects the flow. And then converging nozzles and converging and diverging nozzles. So these are all the different things we're going to talk about with compressible flows. Oh, and I forgot to mention, we'll also look at normal shock waves. Compressible flows are found in a lot of various situations. So they generally show up when you deal with high-speed flows. The general rule of thumb is when the flow velocity exceeds about 1/3 the speed of sound in that flow, then compressibility effects start to become important. And so we'll talk in a little while in one of the lectures about speed of sound. So that's in a lecture when we talk about the Mach number. And so flows where you reach that critical threshold, they typically occur in gases. Okay, the speed of sound in air, for example, at standard temperature and pressure is 340 meters per second. So when you're above about 100 meters per second, 110 meters per second, then compressibility effects start to become important. And that's pretty easy to get to when you're dealing with high-speed aircraft and rockets and things like that. So compressibility effects are pretty important there. The speed of sound in water, which is nearly incompressible, is much higher. It's about a mile per second. So you'd have to have water jet speeds that are approaching 1/3 of a mile per second, which is very high speed. It's hard to get there. Water jets, used for cutting materials in manufacturing circles, those situations, those water jets, the compressibility effects are important there, but under normal engineering conditions, otherwise, you don't come anywhere close to reaching 1/3 of the speed of sound in liquids. It's too hard to get to. So really, compressibility effects are only considered primarily in gases. And so compressible flows are also sometimes known as gas dynamics. So this will have applications, the material we'll be covering soon will have applications primarily looking at, high-speed aircraft, rockets, explosions, where you have shock waves occurring, anything that involves a high-speed jet of air or other gases. So hopefully you'll enjoy the next several lectures on compressible flow. It's really the last major topic in this course, the undergraduate fluid mechanics course. So you're getting very close to the end. All right, we'll end it there.